chapter 11 is all about making predictions. So we're going to start off in this chapter talking about what's called the predicted winning percentage. We're going to explore what it takes to build a better baseball team. The ultimate goal of every baseball team is to win games. Some teams win more games than others. Since scoring more runs than your opponent is the key to winning games, it makes sense for us to investigate this relationship between runs scored and runs allowed. And we'll be using the predicted winning percentage formula to do that. So Bill James, who's one of the original and most famous sabermetricians, they're going to reference him in a movie that we're going to watch soon called Moneyball. Sabermetrician's jobs is to analyze baseball using statistics. He proposed this formula called the Pythagorean winning percentage formula. Okay, and the formula is as follows. RS squared divided by RS squared plus RA squared, where RS stands for runs scored and RA stands for runs allowed. So it says, consider the statistics from the 2008 Tigers, who scored 821 runs and allowed 857. So they want us to calculate the Pythagorean predicted winning percentage. So I'm just going to abbreviate it with PWP, predicted winning percentage, equals my runs scored squared. So runs scored was 821 squared divided by 821 squared plus my runs allowed, which is 857 squared. So we can go and plug this into our calculator directly. Remember, since we have two terms in our denominator, let's put parentheses around our entire denominator when we type in our calculator. This way we can type it in all at once. So 821 squared, there's a little squared key right on the left-hand side of your calculator, about 5, it's right in the center actually, left, 5 buttons down. So 821 squared divided by, put parentheses around your denominator, 821 squared plus 857 squared, and we get about 47.9% if we round. So we can write it as 0.479 or 47.9%. Now it says find the predicted number of wins knowing they played a 162 game season. Well, if we predicted them to win 47.9% of their games and we want to predict how many wins they would have, we can multiply to figure out what 47.9% of 162 is. So 0.479 times 162. And we get about 77.598. Or we can just round that to about 78 games. Or 78 wins, I should say. So the 2008 Tigers actually won 74 games. How does this compare to our prediction? So it's close, but it's a little off. It's 4 games off, right? So it shows that the Tigers won 4 games fewer than what our model predicted. We predicted they'd win 78. They only won about 74. So the 2008 Tigers won about 4 fewer games than predicted. So this difference between what actually happened and what was predicted to happen brings up a term in statistics that we call the residual. The residual is the difference between the actual number of wins and the predicted number of wins. So residual is our actual value minus the predicted value. So that's important, so let's highlight that. So when a residual is positive, so if I take this difference and I get a positive number, that means your actual value is greater than your predicted value. So your prediction was too low. If your residual is negative, then that means the actual value was below the predicted value, so your prediction was actually a bit too high. So let's calculate the residual from the Tigers. Remember, residual is actual minus predicted. So what actually happened to the Tigers? They actually won 74 games. So 74 minus, what did we predict to happen for the Tigers? Well, we predicted 78. So the residual is -4. Since the residual was negative, they performed below the Pythagorean prediction. They won about 4 fewer games than predicted. So sabermetricians often attribute these residuals to luck, or in statistical terms, random chance. Although some argue that ability to win close games helps explain the size of the residual as well. So, this is close. Ideally, our ideal residual is 0 because we'd love for our prediction to be right on. The exact value is the actual. So the ideal residual that we're always aiming for is 0. So some sabermetricians believe, the Tigers, sometimes those of you that play sports, you won some games that maybe you should have lost, or you lost some games, unfortunately, that you maybe should have won. So these difference in the residual not being 0 is explained by this. Maybe some game errors or whatnot that happened that weren't necessarily predicted to happen. Okay? So let's go ahead and go to the back. This one is your turn. So we're going to I want you guys to take a minute. You can pause the video and try this on your own. We're going to keep using the formula from the front for predicted winning percentage, which was runs scored squared divided by runs scored squared plus runs allowed squared. Go ahead, use that formula. Take a minute and try A, B, and C. Okay, go ahead, take a minute and check your answers to parts A, B, and C. So for part D, interpreting the residual. So what does this -2 mean? Because that was your residual in part C. So the 2008 Phillies won 2 fewer games than predicted. Now, we're always going to state what these predictions are based on, because later in the chapter, we're going to talk about least squares regression lines that can make predictions for a variable based on various different variables that you could have. So it's always important in our interpretation of any residual that we state what this prediction was based on. This prediction was based on their runs scored and runs allowed. So is there a better model? Why did Bill James use an exponent of 2? Why didn't he use an exponent of 3 or 4 or whatnot? So here's a general formula for predicted winning percentage with runs scored and runs allowed. We could keep our exponent as a variable. So runs scored to the x power divided by runs scored to the x power plus runs allowed to the x power. And we can try different values to see which exponent works best. As I said before, the residual on the front for the Tigers was -4, and the ideal residual is 0 because then our predictions and our actual values would be the same number. So our prediction would be right on. Okay, so let's try it again. Same data with the Tigers as that example on the previous page. Still working with the 2008 Tigers who scored 821 runs and allowed 857. So this time they want us to use the predicted winning percentage formula having an exponent of 1. So for our exponent, we're just using an exponent of 1 here. So 821 divided by 821 plus 857. So it's up to you if you want to put the little first power, it's up to you. Remember, in order to type this all in at once, you need parentheses around that denominator. So here we get a predicted winning percentage of about 48.9%. Predict the number of games they would have won in the 2008 season. So remember, they play 162 games in their season. Okay, so I need to figure out what 48.9% of 162 is. So I get 79.218, or about 79.2, all right. Or in other words, we'll just round, using normal rounding rules, I'll just round this to 79 wins. So find and interpret the residual. Recall from the previous example on the front that the Tigers actually won 74 games. So for calculating the residual, remember the residual is actual minus predicted. So they actually won 74. We just predicted them to win 79. So the difference here is -5. So our residual is -5. So what does this mean? How do we interpret this -5? The 2008 Tigers won about 5 fewer games than predicted based on their runs scored and runs allowed. Okay, so which exponent was better? An exponent of 1 here for the Tigers or an exponent of 2 that we used on the previous page? Recall that the residual on the previous page was -4. We were only 4 off. Here, the residual is -5. So which exponent is better? The 2, the x equals 2. Okay, why? Well, remember what I told you. Ideally, we want a residual of 0 because then our actual values and our predicted values are the same. And so our prediction was perfect. So here, we're going to pick the one with the residual closest to 0. So we're going to use an exponent of x equals 2 since the residual was closer to 0. Therefore, our prediction is closer to the actual value. So we're always not going to necessarily pick the lower residual. You're going to pick the residual that's closer to 0. So to decide if an exponent of 2 is really the better exponent in this case, we would need to look at all teams in Major League Baseball, not just the Tigers. So we need to look at the White Sox. We need to look at the Yankees, the Blue Jays, etc. Okay? In order to compare which exponent truly makes the best predictions. So an important statistic to know is the sum of squared residuals. It's one way to measure how well the model makes predictions. If a model makes good predictions, the difference between the actual values and the predicted values would be close to 0, or would be small, resulting in a small sum of squared residuals. You could think of this as small or close to 0. You know what? I think I like leaving it as closer to 0 here, or close to 0. So let's put that. Because remember, I told you the ideal residual would be 0. So just a little side note, you don't need to memorize this concept or whatnot for your quiz. But what they do is, in statistics, we like to square our formulas a lot. So for each residual that they'd get from each team, so maybe the Yankees residual is +4, and maybe the Red Sox residual is -2. With each residual, they would square it. That's why it's called the squared residuals. They would square it, and then they would add them all up. That's where you get sum out of it. And the exponent ultimately that gives us the smallest sum is the better estimate, okay? The one that gives us the smallest sum is the better estimate. So take a look at the last example. It says with an exponent of 2, the overall sum of squared residuals for all 2008 baseball teams was 529. However, with an exponent of 1, when they found the residual for each baseball team, squared it, and add them all together in 2008, the sum was 1,215. Which exponent is better and why? Well, which exponent is better? It's going to be the exponent of 2. Why? Because it gives us the smallest sum of squared residuals. And you can abbreviate that with SSR. And the smallest sum of squared residuals means the actual values are closer to the predictions. Okay? You have your topic 1 worksheet for homework tonight. Good luck.